All right, let's see some things about square root functions. This says consider the radical expression root x, which means think about all the things you already know about it, and then we're going to ask you some questions. So, the square root function looks like half of a parabola, and it opens to the right. It goes through 0, 0, because the square root of 0 is 0. It goes through 1, 1, because the square root of 1 is 1. It goes through 4, 2, because the square root of 4 is 2. And I don't quite have room to draw this one, but I'll fake it. It goes through 9, 3, because the square root of 9 is 3. And it keeps on going like that. So it looks like a parabola that opens to the right. What is its domain? Well, it covers 0 and every number to the right of 0, all the positive numbers. It doesn't cover anything negative because you can't take the square root of a negative number yet. We'll show you how later using imaginary or what we call complex numbers, but for the time being we're saying that square roots of negatives are impossible, so our domain ought to look like x can be any real number, comma, as long as that number is greater than or equal to 0. For what values of x is the radical expression defined? Well, basically the same thing we just said, for 0 or anything higher than 0. Is where it's defined. It's undefined for any negative value. Now, they modify it a little bit. They say, now consider the expression root x minus 2. What happens with this one, I won't take you through the whole table of values, but if x is 0 or 1 or anything like that, then you subtract 2 from those numbers, they end up negative, and suddenly you can't do their square roots. So now not only do the negative numbers not work, but 0 is no good, and 1 is no good. The first number that actually works in this expression is 2, because then you get 2 take away 2 is 0, the square root of 0 is 0. And after that, your curve extends to the right just like before. So you get the same curve shape. It's just, we say that it's shifted or it's translated 2 units to the right. So sketch the graph, we did that. State the domain. The domain is now x can be any real number, but that number has to be greater than or at least equal to 2, not 0. It has to be 2 higher because 2 is going to get subtracted off of it when it goes into the function. We have to prepare for that. For the radical expression x minus 2, state the restrictions on x. Basically, the idea is whatever is inside your root, in this case x minus 2, has to be greater than or equal to 0. Because if it isn't greater than or equal to 0, that means it's negative, and that means the square root's impossible. If you want to find the restrictions algebraically, what you do is you take that inequality, that must be greater than or equal to 0 thing, and you solve it. Kick the 2 over to the other side, and you get x is greater than or equal to 2, which is the same thing our domain set up above. This works for any radical. You can take whatever is inside this root and say, you, no matter how complicated you are, you have to be greater than or equal to 0 at the end of the day. So, if they give us a really daunting one, like this, what is this going to look like? Well, I'm going to ignore the order that they said, and let's follow that rule that I gave you just a moment ago. Our radicand, 3 minus 2x, has to be greater than or at least equal to 0. What does that mean? Take 2x over to the right-hand side. We're going to solve this thing. You get 3 is greater than or equal to 2x. Then divide by 2, and you get 3 over 2, meaning 1.5 is greater than or equal to x, or if you write it the other way around, x is any number lower than or at least equal to 3 over 2, is at 1.5. So this curve starts at 1.5, and then it has to go lower than that. It actually has to drop like so. So you get a parabola, but it opens in the opposite direction. It opens left instead of right. This 3 has the effect of shifting the curve a little bit to the right. The minus has the effect of turning the curve around so it opens in the opposite direction. We'll see a lot more about transformations like this later and how they affect a curve. But for now, just working out the domain, this restriction, can tell you which way that curve has to go. So the restrictions on the variable, we said it already, is that 3 minus 2x, the thing inside the root, has to be either a positive number or, at the very least, has to be 0. That's going to be true for any square or fourth or sixth root. And as you can see, it's a big help when you're trying to figure out how the curve will behave.